A function f satisfies the following relationship. F of a plus b is equal to fa plus fb for integers a and b. If f of 100 is equal to 99, what is the value of f105? This is a fun problem on functions, and I thought of making a video on how to solve such problems because this is an important topic on high school math and various standardized tests. So how do we solve these problems? It's a very easy one provided we know the correct way to approach this. So we are given a relationship of the function, how it relates when the values of the variables are different. And in this case, the particular relationship that we're given, fa plus b is equal to fa plus fb, where a and b are integers. So that's the range, or rather the domain of the variables for which this relationship holds true. So since a and b are integers, the first thing that we'll do here is, if we substitute b is equal to 1, we can see how fa plus 1 would relate to fa. So what we're trying to see is, as we increment the value of the integer variable by 1, how does it change the function value? And what we see from this relationship is it increments the function value by some constant, and that constant is basically f1. We don't know what f1 is, what its value is yet, but we know that it's some constant, right? And we can express the increment in the value of the function as we increment the variable by 1. So since we have this relationship, we can now basically write f2 is equal to f1 plus f1. So how do we get that? We just substitute a is equal to 1, and we have basically fa plus 1 becoming f2 on the left hand side, and on the right hand side we have f1 plus f1, and we can write that as 2 times f1. So what about f3? Well, we can basically write f3 is equal to f2 plus f1, right? So now a is 2, so we have fa plus 1 equal to f3 on the left hand side, and on the right hand side we have f2 plus f1. But we already know what f2 is, so we know that f2 is 2 times f1, right? So we just substitute that here, and we now get 3 times f1. So f3 is equal to 3 times f1. What about f4? f4 is f3 plus f1, and since we obtain f3 is 3 times f1, we have basically, f4 is equal to 3 times f1 plus f1, and that will come to 4 times f1. So can we generalize a relationship based on these observations? Well, we can probably write something like this. So for an integer n, fn is equal to n times f1, because that's the relationship, or that's the trend that we have seen by exploring some of these initial values of f2, f3, and f4. Now, one thing that we can do is really cross-check whether this function satisfies the basic relationship that we are given, which is fa plus b is equal to fa plus fb. So if fn is equal to n times f1, what would be fm? Well, fm is equal to m times f1, and fm plus fn will be basically equal to m times f1 plus n times f1, and that will be equal to, we can basically take f1 out, and this becomes m plus n times f1. And now m plus n f1 is simply equal to f of m plus n. So this relationship, the thing that we wrote, that fn is equal to n times f1, that seems to be in sync with the relationship that we're given, which is fa plus b is equal to fa plus fb. So we just established that if fn is n times f1, then that relationship of the function does satisfy fm plus fn is equal to fm plus n. So now that we got this, we can simply write what f100 will be, right? So f100 will be 100 times f1, and that's given as 99. So from this we can, simply solve what f1 is. So f1, remember, it's a constant, right? And we didn't know what that value was, but this relationship that's given, that helps us determine what f1 is. And f1 turns out to be 99 by 100. And now the function is fully defined, right? So we have basically fn is equal to 99 by 100 times n. So what would be f105? So f105 will be 105 into f1. And since we know what f1 is, 99 by 100, we just substitute that. So that becomes 99 multiplied by 105, and then in the denominator we have 100. Now, when you're in a standardized test, you don't necessarily want to spend time multiplying, especially the multiplications are big, and when a calculator is not permitted, this is particularly important to keep in mind that any multiplication by 99, you can potentially simplify it by just breaking up 99 as 100 minus 1, right? And now this really becomes very simple. If you multiply and if you take the parentheses out, we basically are left with 105 minus 105 by 100. And 105 by 100 is 1.05, right? So you have 105 minus 1.05, and that comes to 103.95. So the correct answer for F105 will be 103.95.